Hello student, let's try to understand a problem student. For a reaction A to B giving P student, the rate is given by student, rate is equal to, this is given student, what is there? Rate is equal to constant K, that is A power 1, B power 2. So first order with respect to A and second order with respect to B. The first one you see student, what can be answered? How is the rate of reaction affected if the concentration of B is doubled? Okay. So suppose student, if I will consider the initial condition to be this one, that is R1. So R2 will be student, R2 will be, that is K, A will be as it is student, because the concentration of B is double student. So B is going to be what student? 2B, and that will be the square student. If you consider 1 and this you consider 2, so 2 divided by 1 equation, 2 divided by equation what student? That is 1. So let us see student what can be the answer here. So R2 by R1, R2 by R1 is equal to, this is K, here will be the A, 2B square student divided by K, this is the A, here is going to be B square friend, B square. Let us do student. So R2 by R1, R2 by R1 is equal to K, this is what is there student, A, and here is the 4, this is going to be B square friend, divided by K, here is going to be A student, and here is again going to be friends, that is B square. Dear student, what you can do, B square cancel out, and A cancel out, K cancel out. So R2 by R1, it is going to be how much student? 4. So what is the resulting reaction student? R2 is equal to 4 times of R1 student, 4 times of R1. So this is our required answer student, 4 times of R1. So this is the, hence it is the answer student. If you want to see the answer here, this is the R2 is equal to 4 times R1. Now come for the second portion student. What is the second one? Let us move little bit down student. Okay, here. So second question they are saying student, how is the rate, question is there, how is the rate of reaction affected if the concentration of B is double? This is over student, actually we have to do the second one. What is the overall reaction of the order of reaction if A present is large xn? So it become pseudo order student, PSEUDO, pseudo order, right student? Pseudo order means here rate is given, here what is their rate is equal to K, what is their A, and B square is there. So they are saying excess. So rate will not depend on it, rate will not depends on it, rate will not depends on it, right student? So this is there. So what will be the rate student? Rate is equal to K dash B square. So order will be how much student? Order will be 2. Otherwise it is appear to be here 1 plus 2, that is third order, but it is the second order. If you want to see the slides here, you see student, if A is present in large excess, then the rate of reaction will be independent of A and will depends only on the concentration of B. The overall rate of the reaction will be 2. Now the last portion of the question we have to do student, last. So let us see student, how can we do this one? Yeah, the last portion of the question they are saying student here, a first order reaction takes 30 minutes for 50% completion, right student? So 30% for 50% completion. Calculate the time required for 90% completion of this reaction student. So we can do very easily student this one. Suppose you are having K is equal to student, K is equal to either you calculate what we required here, student, k only required. So 52.303 upon how much is there, student? 30 minutes. 30 minutes. Log here there 50% completion. So initial concentration is 100 and here is how much is there, 100 minus 50 final concentration. So here is 2.303 upon 30, student, and here is log how much is, student? 100 by 50. So it will come 2, student. So 2.303 upon 30 and log 2 will come, student, log 2. Log 2 value you can place plug, student, here. So 2.303 upon 30. A log 2 value how much, student? 0.3010. Now you just simplify it, student. Okay, let me do the calculation here, student. What will be there? 2.303 multiplied by 0.3010 divided by 30. Okay, so 0.0231. Okay, this will be what, student? Second inverse. So k value you got, student. They are asking calculate the time required for 90% completion. So it is going to be very simple, student. So t is equal to 2.303 upon t. Log formula is there, student. What is there? A naught upon a. Okay. So here is, student, 2.303 upon t. Upon k, student, not the t here, dear student. Here we are now calculating the time now. So the second case we have to write k. K value we have done here, student, 0.0231. Log, student, here is the 100 and here 90% means 100 minus 90% completed. So 2.303 upon what, student? 0.0231. Log here what will come, student? 100 upon 10. So 1010 cancel. So log 10 value 1. So 2.303 upon 0.0231 multiply by 1. So let us solve, student. 2.303 divided by 0.0231. It is coming, student, dear student, 99.69 minutes. This is minutes. Means it is the, what is the answer going to be, student? 100 minutes. This is our required answer, student. So time for 90% completion. Time for 90% completion is going to be 100 minutes. This is our required answer. You can check in the slide here. See. So k is equal to 0.693 upon 30. So 0.0231. Directly they got time required for to complete 90% of the reaction. It is going to be 100 minutes. So this is all about the answer, student. Thank you very much for watching, friends.